Hello everyone. I am Egidija Rainosalo. I am representing Centria University of Applied Sciences, and today I will lead the conversation and I will host the meeting, or whatever we call it, seminar, webinar, knowledge exchange event. And today our theme is about valorization of brewing and distilling industry side and waste streams. And Centria is the one leading the event. One of the things what I would say that we call the side and waste streams, but I know that some of industrial people who utilize all the waste and they are not really throwing it away, but using it in the animal feed or whatever, don't like the word waste. It's like black and white. But I think we still can use that word because some of streams are not utilized at all. So I think we are entitled to use that name, even if it's not everybody likes it. Whatever happens now. Okay, so program of today is you all have it. So first I will briefly present what is the project about and what is our technology innovation platform about. Then Mikko Junttila from Centria University of Applied Sciences will overview what is the utilization in the market and how those streams can be processed, something about preservation, how much of those streams are generated and so on. Then we have three cases. One case is from Redono, the Finnish company who is promoting hops farming on brewery side streams. Then we have one case about the spent grade use in food industry and then also in cosmetics products. And finally, we can discuss what could be the future thoughts or what was the message from the event. After each presentation, I think we could have a few minutes for questions and answers, so speakers can probably get the fresh knowledge further, and also the questioners can have the fresh questions and directly with no need to remember longer what was the need to ask. Okay, so our project is having very long name, so it's technology innovation and business models for valorization of industrial waste biomass in sparsely located enterprises. It's a lot of things said in that title. So we have the waste biomass, which we chosen to be the biomass from food and beverage industries. And then it's in sparsely located enterprises, which is in our Nordic periphery region, which is here in green in the map, which also shows that we have some challenges related to the distance between the different companies. Also, we have challenges in the size of companies. They are usually quite small. Remote locations also putting the challenges on having enough waste and having feasible transport costs if some waste is wanted to be utilized in some centralized manner. From the food and beverage industries for the project, we chosen three. I think the main and the most important industries, food and beverage industries in the region. So we have the breweries and distilleries, we have the fish manufacturer, fish product manufacturer, and we have the potato product manufacturer. The main objective of our project was to boost the eco and circular innovations in those industries, and especially in SMEs, and improve, of course, the sustainability of industry. Sustainability, as you know, means a lot of things. It's not only environmental sustainability, but it's also economical sustainability. And when we have environmental, economic sustainability, social sustainability is also coming with. So because we are a public project, so our main goal was to provide companies with the inspirations, so what is existing and what could be done, then provide with the methodology and some tools to develop businesses, provide with the knowledge, give some knowledge about access to infrastructure and what infrastructure is available in the region. And also I think that one of the important is to matchmake with the technology providers and potential new product users, And I think we also, one of the goals having to be the conversation partner for the company and be help in ideation process. And our approach in this is to build a technology innovation platform. In general, it's a website, but in that website, we would have presentation about the services what we provide. So we group those services in the 3 different groups. It's circular economy, business development, and consulting. Then we would have analysis of raw materials and products, and also then technology development. The website is symbioma.eu. You can look to it already. It's open, and we have a lot of information already available in that. Just briefly, I would like just to show or to guide you what to look at, just not to miss. For example, in the circular economy, business development, and consulting, we have it as a roadmap. So because we think that companies are in the very different phases of their development, and then you need the different knowledge at a different stage. You need also different tools at a different stage. And we see that, for example, phase 0, where you are not actively still doing any development work, but you should be active in extracting the different information and just gathering the inspiration from everything around. So if you go to those phase 0, the bar under actually is active. So if you go to phase 0, when you open it, you see the different possibilities of to join events. So we have the sites from the different organizations gathering events into one place, so you can find it from there. Then you can also join the different organizations in your countries who are dealing with the circular economy and with the bioeconomy and anything what is relevant to you. Technology development, we will have 4 main technology development kind of groups of services. So it's technology scouting, where we could assist in finding who is doing what and matchmaking companies or assisting in the value chain development. Then we have the sustainability analysis, so we can make the material and energy audits and also perform LCA and LCC, so life cycle assessment and life cycle cost assessment. But also we can assist in the technology development tasks like laboratory research. So if something is very new or something needs to be tested fast, we can do it in the laboratory scale. But I think what is the most of the value is that we have the pilots. So with the pilots, we can assist in providing the needed amount of materials for example, your end user or the user of the material you would extract from your side streams. Our approach is also to have one place from where assistance can be asked. So we know that we all are project organizations, so people are changing. So we thought that if we have the common email address, so somebody will grab out of an email, and because we are networking between each other internally, we can share that with the party which is the most relevant to the question. So if you have any questions, just use symbiomaoutlook.com. Then here under is the bar with the 3 different industries. If they are also active, if you go behind it, there is a lot of information, the general information, what is happening in each of the industry segment and with side and waste streams in particular. But also there are more specific reports, for example, if about breweries, so it's about the preservation, about the protein extraction, about the, we will also have some cases what we are developing in the project. So not to keep longer, I hope that we will have very informative day today, and I hope that all of us will learn something new. Like, you know, every time you meet a new person, the person knows definitely more than you or something else than you know. So we always learn something, and let's be today a start of also something new in our industries and in our research areas. So thank you from my side, and I think I am giving words and further to our first presenter. So Mikko Junttila from Centria will further deal with the brewery industry. sharing.
Can you hear me now?
Yes, we can, but we don't see it.
I'm just trying to open the file, but there seems to be okay now.
No, it's good.
Is it okay now? How do you
Yes.
see the slides there now?
Yes.
Okay. Hello all, my name is Mikko Junttila. I work as an R&D specialist here at Centria University of Applied Sciences. In my presentation, I'm going to talk about the different utilization methods that have been developed to increase the value in the side streams that are emerging from distilleries and breweries. I will start this presentation by going through the brewing process and explain what the side streams from those that processes are. Then I will go further in details to explain what kind of material Brewer's spent grain is. We have done a small experiment here at University of Applied Science how we can preserve PSG, and I will tell the results from those experiments. Then I will go to the actual utilization methods for Brewer's spent grain. I have grouped them in 3 different categories. The first group is utilization methods where Brewer's spent grain is used as such or only minor changes are done to the material. The second category is utilization method where this material is used as feedstock for production of high-value chemicals. And the third category is extraction of high-value components from Brewer's spent grain. And at the end, I will also show some utilization methods for Brewer's spent yeast. Here is the brewing process and what are the side streams from the brewing process. In this table is presented the average amounts of these side streams when 10,000 liters of beer is produced. The spent grain comes out from the mashing process. It is the largest side stream from beer making. For 10,000 liters of beer, around 2 tons of wet spent grain is created. In the next step, brewing, hops are added to the brewing process, and when they exit the process, they are spent hops, and there is about 0.6 tons of spent hops from that process step. Next is the fermentation, in which yeast uses the sugars in the liquid and turns them into alcohol and carbon dioxide, and then the yeast is removed from the process. About 0.3 tons of wet yeast is created for 10,000 liters of beer. And in the final manufacturing step, Kieselguhr can be used for clarification. A small amount of Kieselguhr is also a side product from this process. And the water usage is quite high in these processes. Even up to 10 liters of water is needed to produce only 1 liter of beer. And for 100 liters of beer, about 20 kilograms of grains is needed and 150 to 900 grams of hops. Then what kind of material is Brewer's spent grain? It mainly contains the grain husks, pericarp, and traces of the endosperm from the molds, and the water content in this is quite high. It varies from 65 to 80%. And the dry spent brewer's spent grain is a quite complex mixture of different components. The amount of these components can vary quite a lot. The main components are hemicellulose, which is arabinoxylan in this case. It varies from about 22 to 42%. Then there is cellulose. Little bit of starch can be still left in the material, 1 to 12%. And proteins varies from 14 to 31%. Then there is also lignin, small amount of lipids, and phenolic components. Because of the high amount of water and also due to protein and carbohydrate content, bacteria likes this material and they start to grow there very rapidly. We have done a small-scale experiment here to study how this material can be preserved. We had 6 samples. One sample was such that we didn't do anything, we just kept it in a plastic container and monitored how much the bacteria growth in that material. Then we have one sample in refrigerator in 4 Celsius degrees, one was in freezer. In 2 of the samples we added acid, one formic acid and acetic acid to do the preservation, and one sample was dried in oven in 60 Celsius degrees so that the moisture content was less than 10%. And in this graph there is the bacteria count in each of these samples. In x-axis is the days and in the y-axis is the bacteria count. And as you can see, the sample that nothing was done to preserve it, but it was kept in the room temperature, it was spoiled very rapidly. In a couple of days the bacteria amount grows quite high. Also the sample that was kept in 4 Celsius degrees, it also spoiled quite rapidly. In 10 days the bacteria count in this sample was very high. Also the acetic acid wasn't as good as the trace 3 in preserving brewer's spent grain. Drying formic acid and keep it in frozen stored the samples more than 200 days. Drying looks like a good way to store the brewer's spent grain, but it's quite expensive way to remove the water from the material. There are also mechanical dryers that can be used for that. We haven't done any experiments with mechanical dryers, but you can find more information of those mechanical dryers and also more information about the drying of the plant material in the report that we have written. Then let's go to the different utilization methods that have been developed for the brewer's spent grain. The first category was such that the BSC is used without any major processes done to the material. Brewer's spent grain can be used in building materials. It can substitute sawdust in brick manufacturing processes. It increases the porosity of the bricks, and it also improves the characteristics of the bricks without having any influence on the color or the brick quality. Also, this brewer's spent grain can be incorporated into brick making production without having to do any alteration to the production process. And then there's developed different kind of packaging materials that are made from the brewer's spent grain. The first example here is such that there hasn't any additives haven't been added to the material, but it has used as such to do the packaging material. It's a compression molded process in which the proteins is said to act as a natural binder. Since anything hasn't been added to this material, it's easy to compost, and the developer is the material. They say that maybe this is best for promotional products for large events or that kind of things. The other packaging material is a hot pressed brewer's spent grain with potato starch as an additive there to function as a glue. And the developers of this material say that this can replace in some food packaging applications expanded polystyrene. Then brewer's French grain can be used also as a growing medium. Mushrooms have been grown in brewer's French grain. If a PSG is colonized with mushrooms, it has been noticed that the mushrooms grow 2 to 3 times faster in the PSG than media that is usually used in mushroom growing. And after this colonization, PSG is mixed with the sterilized sodas and food chips for the fruiting block. And if this PSG is used immediately after the brewing process, there is no need to do any pasteurizing, which means that the process is even more economical. And it has been found out that there is a significant savings for every growing log if a brewer's French grain is used as a material in these applications. And after the harvesting, the residua is claimed to have been richer in protein than brewer's French grain, and in some parts of the world it can be used to feed cattle, for example. Also, insects have been grown on brewer's French grain. There's one example where worms have been grown in chicken farm, then to feed chicken. In 4 to 6 feeds, the protein amount was increased at least 2 times. And then if this method is used to grow the feed for chicken, it can be concluded that there's less need of land and less water for fertilizers are needed in the growing process. The next example of valorization for brewer's French grain is more like at the moment in a research stage. There are several papers published where brewer's French grain has been used in water purification. Studies show that this material, it can remove heavy metals such as cadmium and lead, and also synthetic dyes from water, both in batch and continuous flow systems. And the efficiency of this removal depended on what was the particle size of the brewer's French grain, how much this material was added to the water, and what was the pH of the liquid. And one can find several examples where studies published that show that brewer's French grain can also be used as a fuel and used as an energy source in microbreweries. I am referring here to a report made by Sperandino et al. They have made a technological and economical study of small-scale pellet plant to convert the PSG from small breweries for fuel. Due to high carbon and hydrogen amount, the calorific value of a brewer's French grain is close to most common forest species that are used for the energy purposes. And in this paper, they made the calculations so that the capacity of the pelletizing plant was around 100 kilograms per hour when 6 millimeter diameter pellets were produced. And in this table is presented the production costs in different levels of production volumes, and also what are the unit costs. And then they have also compared these unit costs to the wholesale and retail prices of pellets. And in this study, they found out that making the pellets themselves, it was much more economical than buying from wholesale or retail prices these pellets. The higher the production volume was, the higher also was the economic difference between the pellets made self or pellets bought from the market. And the second category of utilization methods is where BSG is used as feedstock for production of high-value chemicals. There is a list of chemicals that have been produced from Brewers Brent grain: bioethanol, lactic acid, biodiesel, xylitol, polyhydroxybutyrate, polylactic acid, acetone, biobutanol, and proteins have been produced from BSG. Most of these are enzyme catalyzed processes, which means that when these kind of processes are done, the capital costs can be quite high, and also the operating costs can be quite high in these kind of processes. And also specialty know-how is needed to run these kind of processes, and also appropriate facilities. Most of these are still in a research stage. Not much commercial production has not emerged yet, except for the proteins. A certain type of fungi is grown on the BSG to increase the protein amount there and also the fiber content. And then this meat-like structure is obtained that can be used in food products to substitute meat. And then there's one commercial example where one of these processes is used on a larger scale. In Scotland, they are building a facility where they are using APE called process. They are making acetone, biobutanol, and bioethanol from the whiskey distilleries, draft and pot ale. And the third category was the extraction of high-value components from the BSG. This is something that we have been working on here in Kokkola. We have been trying to develop a method where we can extract both proteins and arabinoxylan from this material. And in this picture, I have envisioned what the process could look like, what are the process steps, and what kind of process equipment is needed if someone wants to extract proteins and arabinoxylan from the BSG. First, there's a pre-treatment stage, which is an acid treatment. Then usually the protein extraction is done in alkaline conditions. In this step, both the proteins and the arabinoxylan will dissolve in the liquid. Then the remaining BSG is separated using centrifuge, for example. Then there is a liquid which contains the proteins and the arabinoxylan. Proteins are precipitated by adding acid to the liquid, and then the proteins are separated and dried using, for example, belt dryer. The liquid fraction contains now the arabinoxylan, and it is separated from the liquid by adding ethanol there. It will precipitate, and then it will also be separated from the liquid using centrifuge, for example. But what are the challenges in this extraction process? There's a large amount of lignin, and it is difficult to get the protein-rich extract because this lignin also dissolves in alkaline conditions and it precipitates at same conditions that the proteins does. So the protein content in the protein extracts is about 50% without any purification steps. Also in this process, high temperatures are needed or large amount of chemicals that can make this process not very profitable to do. But there are new extraction techniques emerging that maybe can help in this situation. There's, for example, subcritical water extraction. Here in Kokkola, we have a small-scale equipment where we can do this subcritical water extraction. We have this accelerated solvent extractor. If this is used, the extraction is a bit more simple to do, and also the protein fraction is more pure than in the previous method that I explained. Around 60% is the protein content in the final extract. Then the new technique also is this disruptive destructive extraction. At least the provider of this extraction machine says that proteins can be extracted from BSC using this machine. Then there is a list of different applications that can get from the brewer's brand yeast. There is the partially autolyzed yeast, yeast cell wall, yeast extract, and active peptides. They all have different applications where these can be used. And there is one example where one of these processes have been developed so that there is a pilot scale plant in a microbrewery. A company called BDI Biotechnology has scaled up this production to a yeast extract in a microbrewery. They have concluded that it's technically and economically feasible to do this kind of operations. They have also tested the products that they get from this process in pharma and fermentations and also beer brewing. And the yeast extract that they obtain in this process, they have also done food prototypes such as crackers, hot and cold beverages, and bouillon cubes. And in this slide, I have made a rough summary of these different valorization methods. What is the estimated value added into the brewer's brand grain? What are roughly the estimated capital cost and operational cost if these kind of utilization methods are used? When the brewer's brand grain is used such, one can estimate that the value added into this side stream is not that high, but the more processes are needed in the process to make new products, the higher the value is, and also higher the estimated capital cost and operating costs will be. And to the end, I will add that in addition to the report that I mentioned earlier, we have also two other reports. One is focusing more on the side streams, what are they like from the brewing and distillery industries. And the third report is about these different valorization methods that have been developed to increase the value in the side streams. Thank you.
Thank you, Mikko, for very nice presentation. I still have to mention that the reports Mikko was mentioning will be placed in technology innovation platform, so you will have in this SYMBIOMA.eu. They are not there yet, but I think in the very near future they are there. But any questions to Mikko? Quiet, so I think we have to give screen to another speaker and just be brave to ask. And I will leave, of course, at the very end also the slot for questioning, but I think presenters probably would like that you ask directly because the presentation is fresh and then questions are probably fresh. But okay.
All right, yeah. Hi, everyone. My name is Henri Laine. I'm the founder and CEO of Redono Oy. I'll be sharing you a little bit about our story and solutions, how we've built on how to establish sustainable breweries with help of recycling the side streams for their own hops production. I'm just gonna put up my screen here. Let's see. I think you can see my screen now.
Yes, we can.
Okay, great. All right, so Urban Hops Farm, and let's go. So this is kind of the challenge that we've taken into, and realizing, as Mikko also showed a picture of, just the brewery process itself uses roughly 10 liters of water to produce 1 liters of beer. If we look on the whole production chain, when we go back to the agriculture and the farming of different raw materials, and the whole chain of water that is being put into a pint of beer is roughly 75 liters. And the amount of CO2 and the competition in the whole brewery business, it's difficult, and you always need to somehow compete and come with your exclusive story on what makes you kind of the better product and better brewery than the next one. And also realizing that when you produce a pint of beer, that there's always left over with some side streams, some byproducts like we are discussing about today. And usually also a lot of these breweries are pretty dependent on the same raw materials which they use to produce their excellent products. The imported bulk ingredients, which usually in beer is, as we know, the grains and the hops. And the hops is of course considered as kind of the soul of the whole beer. Now we've tapped into this kind of challenge and came up with this solution of recycling the side streams. So this is, as we could see from Mikko's previous presentation, from these different side streams, we've analyzed and researched mainly what is left over from the fermentation tanks, the kind of the yeast material, and that's separated into the liquid. So that's what we are interested in, kind of the organic, you could say, wastewater, but what we usually look is that's highly nutrient rich waters without other chemicals from cleaning, for example. Okay, now these side streams, we could in this picture, the brewery, we can take these side streams, connect it locally with the biofeed system, which is our patented method and system for pre-treating and purifying these different side streams. And the piece that produces from these side streams fertilizers for further use. So these can be recycled back to the brewery's local farmer that farms and produces the, let's say, the barley for the malting process. But we are more looking into how to connect local food tech, ag tech systems next to the brewery. We have, of course, we also have technology and solution for traditional vertical farming and also microalgae production. But we simplified this picture for breweries to concentrate more and look into the possibilities of grow your own hops using your own side streams. And of course, in every fermentation process, there's some CO2 that is also being produced, and we know that the plants they need CO2 to grow in their this photosynthesis process. So we've developed this indoor hops farm that we are here calling Urban Hops Farm. We piloted this earlier in Vantaa Urban Farm Lab, and together with a couple of breweries piloted and kind of built the proof of concept of how this can be done, and now ready to build the next kind of commercialized systems as well. And so in the end, this brewery now, with help of our solutions, can now use their side streams to eventually produce their own fresh hops. So in at least in the US beer markets, there's a lot of new beers coming out with wet hops beer using fresh hops, aromatic hops to give a new type of tastes for the beer. And actually the problem also in our area that the hops growing is it's short season, And when you go indoor, hops hydroponic farming solutions, you can even get 3 harvests of hops per year, and you're not anymore fully dependent on these. Usually the hops for breweries, they come in these kind of dried pellets of different hops. And so here we are bringing a solution where the brewery can, on their own premises, grow their own hops, or we can take it as a service in our larger farm, collect these side streams to produce the fertilizer, and then in our large scale farm we can as a service farm the hops for the brewery. Now, breweries might ask, what's in it for me? This slide shows a little bit about what makes this now the brewery, the uniqueness. So we look at this, that when how much resource is going in now to making a pint of beer, and all that resource, we're trying to save the resource. So when I had the first slide where 75 liters of this water goes to produce a pint of beer, and mainly this water is going for the agriculture. So I think that's kind of taking up roughly 90% of the whole water usage going to the farming. And when you go into the hydroponic solutions, already they are using 90% less water than the traditional farming, and that's due to recycling the water and the nutrients in a kind of closed loop to the farm. So saving the resource, that's one point. So when you save resource, you could say that we can also save money and eventually creates more income. But for your story, it's kind of, you get more of that pure and fresh local urban hops. So that gives a whole new story to your beer, that we use our own hops. You can even brand your own hops, maybe come up with an Arctic hops brand, make beer for the Japanese market, and say that we are growing our Moomin hops here. And that would be what we sometimes call bangeri. But the image and the story, that creates a new brand value, and I believe that is also a lot of consumers also, they find these stories to be appealing, and it's something that they also wish many times to support. And also what you could see from here, as from the resource aspect, that you create less of that wastewater. We take that to use advantage and use it as fertilizer, and all that treatment costs you get lower. And nowadays we are looking into that even more and more. We're getting CO2 taxation and all that. So now we have a solution for the breweries that we can just bring from fermentation tank a CO2 line to the farm, and that's being kind of uptaken by the plants, the hops plants next to the brewery. And pure local, this is also something that we've been kind of building on, a brand that one day we see that this could be something that could be maybe next to your kind of beer brand, and have some kind of pure local brand to the side to tell the story that this beer has been brewed with next level sustainable urban farming technology through circular economy, sustainable developments, and all that kind of embedded in this one kind of pure local brand. And this one again, we can see here kind of the different innovations around this. You are a brewery that is kind of considered as the forerunner, creating a sustainable brewery model. Use fertilizers for the barley production, even more sustainable production. Story behind your brand and creating new value for the brand. You're unique and you differentiate yourself from other competitors on the market, and you are unique by using fresh local ingredients, and even the beer, you can come up with new recipes with even greater tasting beers with fresh aromas instead of drying, where you kind of kill maybe some of the parts of the hops there. And all that, what's now pretty actual is this all that circular economy and sustainable development. And once again, kind of less of different wastes, and recycling the resources, and some with the solutions. What can create all this greatness is with our biofeed and urban hops farm. But you could also connect this vertical farming for other food products. If you have a brewery restaurant, you could offer maybe some tasting at your brewery, put some freshly grown lettuce between your burgers when you taste the beer, and add to that story that you are also a hero that produce local foods with vertical farming, microalgae maybe for new. I guess we're gonna hear about cosmetic ingredients and some animal feed was also mentioned, but also macroalgae can be even further developed into new superfoods. I've even heard that some brewery did from microalgae new ink that they labeled their packaging and everything with microalgae produced ink. That was pretty interesting. And also the whole biotech recycling system that gives a story of how you kind of make yourself to stand out as a more sustainable player. These are some of our collaborators we've been working with, and very happy to have been privileged to work with these breweries, Tornion Panimo and Rock Paper Scissors. So Tornio, of course, from Tornio, and Rock Paper Scissors, RPS from Kuopio. And these two heroes has been very happy to work with us and are eager to become kind of the forerunners and to also more now discussing and looking into how can we commercialize these systems for them and together. Here's our team. So I'm Henri Laine here at your far left. Next to me is my beautiful wife, who is the co-founder of Redono, and she is now looking also more into product development of even further refining these different plant products, and also looking into these cosmetic ingredients and more in the microalgae side. Isa takes care of our financial management, Kari our business development strategic wizard, and Pasi head of our marketing and brand. And in a nutshell, again, this gives you a competitive advantage, separates you from other breweries definitely, and your brand, your story really gives more awareness also to the consumers that hey, these guys are doing something unique. And our goal with all these kind of zero goals for also bigger breweries, zero waste and all that, we're getting closer to this, so that we are looking into that it's possible that we have kind of a closed loop of a brewery where we can recycle everything that comes out from the brewery, taking advantage of that and putting it into other systems. So this whole event, I'm happy to be here, and as also to hear from others what kind of solutions we're looking into to how to recycle these different products. Yeah, cheers. I think this was my part. If there's time now for any questions or anything, I'll be happy to answer now, or maybe later on this event if something pops up, and I'll be here. If there's something you can put in the chat, and we can start a conversation there also. Thank you.
There is one question. Thank you very much. It was very interesting presentation. I would have a lot of questions, but I think I give to someone else time to talk. But there is one question in the chat. Is pure local like accreditation system like Michelin stars, Guinness Books of Records or something like that? Or should we run for it?
Yeah, maybe I missed a little bit. Is it in the chat?
Yeah, it is in the chat.
Okay. Now, I'm sorry, but I think I have a good English, but I'm not sure what this accreditation system really means.
Akkreditointi.
Still, no, nothing.
They have usually some labeling systems where when you do the accreditation, somebody is coming to audit. How do you do things, and if they are right?
Oh yeah. Okay, so like for a standardized kind of.
Yeah.
Okay, yeah. Well, you could do that. It's more maybe of a brand value that this beer has been produced with kind of recycling of side streams to their own hops, but I don't think it's a kind of you could build this on into kind of to make it a standardized production way of doing the beer, but that hasn't been the initial idea behind it, but good comment, good idea, and why not? This could be even further developed towards this, definitely.
I think
Or
we have
rating system, yeah.
one question also. Mette wants to ask something.
Yeah, thank you very much. It was interesting for your presentation. Are you using local Finnish hop in your production?
Yeah, we've piloted first. Our first pilot was with the Cascade hops, very kind of typical hops, and that was mainly used also to see that can we grow even these more traditional hops with it indoors when we have a controlled environments. And now our next pilot has been, now we've had some experience also with the local hops. They yield a little bit different. They are kind of smaller cones, are kind of local strains or varieties. And from our experience, we could see that the yield of the hops itself was bigger from these kind of more commercialized hops that also already been kind of further developed maybe towards this. But yeah, these local hops are something that we are super interested in and already are running in some of our platforms.
Then I was curious about the hydroponic systems. Could you tell me the size of the system? Because I've tried to grow hops in plastic tunnels, and we have also had in the greenhouse. So I was curious about the size that you are running the system in, the heights, and have you got any?
Yeah. I have another picture here from one of these pilots that we have, but let me see if I can kind of get it somehow up here now quickly. But yeah, our first pilot system was containing 20 pots, and that's kind of a if you're familiar with different techniques, we use the Dutch bucket system for the pots that we have let me see, it's easier with the picture, so just if you bear with me, I'll share my screen again and open up another picture here. Where are we? Okay, I guess you can maybe see this one.
Yeah.
Okay, let me get this in full screen. Okay, so this is the one pilot, and I have another picture where we're from this actual pilot, but this is a kind of a more 3D image of this, but gives you the idea. We had kind of on the left side that we had this, and then we left the right side of this, which now shows no plants. We had other plants also there growing. We did some strawberries and other what is this, lakkamare, cloudberries. But that's basically, we have these hops plants in different pots, and they're connected with water kind of drippers. And then from the bottom of each pot, we collect into kind of a running line that goes back, kind of a wastewater line, to a recirculating tank, kind of the nutrient tank, which is connected with, there's a pump in the bottom of that, and that pumps back the water to the drippers for each pot. So if you go Google Dutch bucket system, then that's kind of the technique that we've been using to build up this system.
Okay, yeah. Well, I might take contact to you to hear more about the system.
All right. Yeah. Excellent. Yeah.
Have you got any figures on the production per plant? What the yield is per?
Yeah. It's roughly we've been came up to kind of a rule of thumb. Some plants, they vary. They got kind of a incline in each other, but doing this well, you can go up with kind of 1 kilo per plant.
That's dry hops.
That's fresh.
Oh, okay. Yeah.
If you go with the kind of cascade, you leave more space for them to grow. You can go up to 2 kilos per plant.
Okay. Okay, thank you very much.
Okay, thank you. He had some question to ask also.
Yeah, hi. I hope you can hear me.
Yes.
That's presentation. Thank you very much for it. I just had a follow-up question because You did highlight very well that the implementation of the solutions now can actually save money, through saving resource. But I was just wondering, with regards to the brand value that you're talking about, have you actually identified that there's, say, increase in sales or more consumer uptake due to the circular economy solutions that have been put in place?
I can't say directly that I have kind of a certain figure for you to present that the sales increased by this and this, how much percent. I can't really say. Kind of what I'm referring to is kind of that kind of common, I think, consumer changes. What's happened? What is the kind of values that consumers are having when they do their kind of their purchase for each product? And I think that's kind of a more kind of a common way to look at that the nowadays people are more concerned about the environment and how they can have an impact on these kind of more positive changes, and wants to support chocolate that is fighting against slavery in chocolate business, or recycled kind of clothing and something like that. And so I think it's kind of a cultural change that is kind of driving us towards this.
Okay, thank you. And
okay, yeah, thanks. I think that was part of my question, actually. Sorry, because I know people these days, they say they want to consume a bit more greener. So I was just wondering if you've actually observed that there has been an increase in such sales.
I can't really say, but I know from I worked with the Tornio Panimo. They also launched a beer earlier that was done with the traditional hops farmer, and they collected all their hops from that farm to produce a beer with kind of a local hops, and it was kind of a special batch. And at least I heard from these guys that the whole batch was sold in just a couple of days. It was people were really loving it, just because of the story that it's from a totally kind of in kind of our own hops grown on our own kind of land. So something special, and there's a lot of beer lovers here. So when you come out with a totally new story, people want to taste and try out that what is this.
Okay, there are few questions in chat, but I think if just fast answer.
Okay, yeah, I see a question from Marts, okay. At least, that can this fertilizer be used for hydroponic culture of other plants? Yes, like I mentioned also in that picture, we used these same fertilizers in a kind of a traditional hydroponic system of NFT and ebb and flow to grow berries, and super happy. I think we were the first that actually could grow hydroponically produced cloudberry. We got one berry out, but at least it's something. And we got some strawberries. They were happy, and yeah, we are representing also vertical farming solutions technology, and so that's one thing that we could definitely also connect to this. Have a containerized vertical farm next, also for other plants.
I could very fast add to it. My mother is actually watering her tomatoes with a yeast, so she's buying yeast from the shop, dissolving it in water, and then saying that it's growing better. So I think the old people knew very good how to fertilize their plants. So there is something in there. I think that it's possible to look for other plants also.
Yep. Okay, so were there any other questions?
Yeah, I think we should move maybe to our next presentation if the chat could go on. So I think that Henri can answer to chats if you still have questions.
Yeah, sure.
We'll just
I'll do
keep
that.
up with some schedule. Okay, thank you, Henri, very much for the presentation.
Thank you.
Next, our speaker would be Rossana Coda, and she will talk about the use of the Brewers plant grade in food industry. So, screen is yours.
Thank you, Egidija. I will now share the screen. Thank you. Yeah. Good morning, everybody, and thank you, Egidija, for inviting me here. I am Rossana Coda, and I am a principal investigator at the University of Helsinki, and my expertise is food microbiology. I've been invited here today to talk about some of the results of our project that has recently concluded on the use of brewer spent grain. So I won't go into details anymore because we have heard a lot about how brewer spent grain is done and what is the issue is produced so abundantly. There are also issues in its reuse in the food chain because brewer spent grain, because of its the way it's made, it has poor technological quality, it has a lot of lignin and different structure, and that's why current main destination is animal feed, and it has also actually a very low market value. However, in spite of all of these issues, brewer spent grain is also a very nutritious raw material, and if used for human consumption, it could contribute to healthy diets and reduce food waste. But let's see how this could be done. This is the project that I was talking about. The title is Biotransformation of Brewer Spent Grain, Increased Functionality for Novel Food Application. This project was funded under the work frame of Horizon 2020 of the SAS Food Call, and nothing new for you to say. From the beer making process, our intention was to utilize the brewer spent grain via functionalization with technologies that we developed, and then to use it as ingredient in novel food application. So our main objectives were, first of all, to establish these simple bioprocessing technologies to improve the quality of brewer spent grain as food ingredient, to understand how these changes that we were inducing would affect the properties of brewer spent grain, and to evaluate the quality of food containing brewer spent grain. So these were the categories of food products that we used as proof of concept in the study. They were bread, pasta and breakfast cereal, so cereal-based food, because this is a natural complement for this type of food. The research partners were the University of Helsinki, two Italian universities, the University of Bari and the Free University of Bosen, and also we had RISE in Sweden. We also had some industry partners. They were mostly in-kind contributors, and they supplied us with their brewer spent grain, and they also conducted some of the industrial trials that we will see today. I want to just make a short premise why we wanted to use fermentation technology to functionalize the brewer spent grain. As all the agro-food byproducts, most of the times they have high nutritional value, but they are underexploited because they have several issues. For example, they have anti-nutritional factors that are not very encouraging from the nutritional perspective. They tend to have poor technological performance. They might have low structure forming capacity, but they sometimes bulk density. So this makes it difficult to use side stream as such as food ingredients, but there can be also other reasons that might be economical. Fermentation and especially bioprocessing, so could be a combination of fermentation or the use of enzymes or both, can modify the raw material in a desired way. So bioprocessing can be tailored to solve some of these issues that make these side streams not very easy to use. The bioprocessing strategy of brewer spent grain in our project focused especially on two aspects. First of all, the production of antioxidant compounds from the brewer spent grain, and then the synthesis of dextran via lactic acid bacteria fermentation. Why these two properties? Brewer spent grain in itself is very rich of antioxidant capacity. There are different phenolics compounds that are just entrapped in the cell wall of the spent grain. So via bioprocessing, they could be liberated and then be released in the raw material. And dextran is one way in which we can functionalize very challenging raw material thanks to lactic acid bacteria fermentation. So some lactic acid bacteria are able to synthesize this natural hydrocolloid that is able to improve many technological features in food. For example, it can give bread with higher specific volume, lower stalling rate, and also it can mask some difficult sensory attribute. So this is the first case that we will look at today, how bioprocessing of brewer spent grain was used to produce a functional pasta. There has been some, of course, preliminary study on how to do the bioprocessing of brewer spent grain most effectively to release antioxidant properties. And this, in a nutshell, this process involved the use of oxylanase and then a fermentation with selected lactic acid bacteria. This bioprocessed brewer spent grain was then used as ingredient for the making of pasta in a very simple and classical protocol, and we obtained then a fortified pasta containing semolina, durum wheat, and part of this brewer spent grain. We have then assessed what were then the properties of this brewer spent grain pasta. We have done different type of analysis, the technological quality of the pasta, but also the sensory profile. So you can see here some of the pictures of our result, and compared to the use of untreated brewer spent grain, the pasta containing bioprocessed brewer spent grain had, first of all, a better look, and it was more homogeneous in many ways. It kept the cooking time better compared to no treatment done to the brewer spent grain. And also we have noticed via this sensory panel, this is a picture of our team done at the University of Helsinki, that the texture, perception, and chewiness were improved by bioprocessing. And we did not notice any special off taste. On the contrary, the pasta resembled quite much a whole grain type of pasta. Besides this improvement in the technological and sensory properties when bioprocessing was applied, we also have to say that there were other positive aspects in producing brewer spent grain containing pasta. Because of the recipe, we were able to meet the claim in high fiber because there was 8% of fiber content, and also source of protein. And other analyses were done showing that the glycemic index was lower compared to regular pasta, and the bioprocessing improved also other features. For example, we had improved protein digestibility, and generally other nutritional quality indexes of the pasta, like the essential amino acid index was higher, and generally the pasta also on the protein level was more nutritious. What also we were able to assess was the retention of this antioxidant capacity that we induced during the bioprocessing of the spent grain. We noticed, actually we studied that even after cooking, these properties conferring improved antioxidant quality were retained quite significantly. We were then able to say that the use of bioprocessed brewer spent grain in pasta formulas gave many benefits. It improved the general use of brewer spent grain as such as ingredient in pasta because it conferred better technological and sensory quality, but it also had very relevant nutritional properties and the ability potentially to provide compounds beneficial to the diet, which are these fiber and also antioxidant compounds. There is, if you're interested, also an article that came out from this work. To the second case now, we have also studied how bioprocessed brewer spent grain could be used to produce different types of baked goods. We have done this experience together with an Italian company that is an SME. It's called Valorisation. It's in the south of Italy, and it is a company that works very much on reutilizing side streams from the agri-food industry in their production line. So first of all, as I mentioned before, the protocol that we worked on was how do we ferment the brewer spent grain and try to make it better compared to what would be without any processing at all. So in this case, fermentation with lactic acid bacteria producing dextran was set up. And this is the result that I think is probably quite easy to observe compared to wheat bread. Of course, the use of brewer spent grain alone in the recipe, especially at this level of substitution in the dough, can be detrimental to the overall quality of bread and gives a lower volume and a higher hardness. However, when fermented brewer spent grain was used to produce bread, we can see that there is sort of restoration of this capacity, and the bread is actually softer and it has higher volume. In fact, we had 30% more volume, 40% less hardness and stalling rate compared to the use of brewer spent grain without any processing. This is because dextran acting as hydrocolloid was produced in sufficient amount to enable this quality then in the bread. And also in this case, we have established a recipe that would meet the claim according to EU regulation of source of fiber and source of protein. This is an experiment, is our work done at the University of Helsinki. We also did a small sensory panel in this case, and we noticed that there was higher odor intensity and homogeneity for dextran containing bread, which is this brown line here in the chart. And there was also higher moisture perceived and more softness compared without any use. Any fermentation done to the brewer spent grain. So how this was then transferred to the bakery in Italy is that they reproduced the protocol that we developed at the University of Helsinki with a slightly adjusted recipe, of course, depending on the type of raw material that they had. And they made a different type of products with this fermented brewer spent grain. This is, for example, one very local bread that is typically used as a type of sandwich in the south of Italy. And what did they notice after this experiment is that the results were overall appreciated by internal panel, and the product were judged similar to the whole grain types that they also produce. Their recipe also were able to meet the claim high in fiber and source of proteins, and you can see here in the different colors in the chart all the different products that the company did. There were different type of pizza base, different type of focaccia, as you might know, that's also very typical Italian type of baked goods. And we were very pleased to see that even if there was a sourdough type of process involved, the acidity was actually pretty mild and not disturbing at all. And sometimes there was a significant improvement in elasticity due indeed to the presence of dextran. What I want now to say is there is still a lot that can be done in terms of use of brewer spent grain in food products. This is the result of a master's thesis student that has made some sort of questionnaire to different consumers. It was a small panel, but the results were very encouraging because 80% of consumers expressed quite some interest in utilizing, in eating products that contain brewer spent grain. And this makes a lot of room for food industry to think about innovative use for this very nutritious byproduct. Of course, also in co-creation with consumers. A few takeaway message, and these are the learnings really from our project that we as researcher finally came to observe. We can say that proper processing ensures good technological and nutritional quality. We worked especially on tailored fermentation and bioprocessing. So with that said, we are able to indeed modify significantly the properties of this challenging raw material. We can get a material with a high nutritional value even better if we think that we are able to induce higher antioxidant properties, and in general this bioprocessing technology can increase different nutritional indexes, including digestibility. And we have also observed that cereal-based products are a great fit for the use of brewer spent grain. Barley is a cereal in itself, of course, and they can also be considered an easy way to deliver more fiber. They blend well into the attributes of cereal-based food, and they can ultimately diversify a healthy choice for consumers. And this is, of course, my most sincere acknowledgement to all my partners in research, the funders, and really everybody, students and panelists who worked in our project. And thank you very much for listening.
Thank you for very interesting presentation. Just quick question. Do you know if somebody in Finland is already using spent grains in some food products?
I'm not sure if this is going on in Finland, but it's definitely going on around the world. There are commercial products. I'm sure about the American market, like for example, extrudates of different type. And I know that there is a startup that is has started very recently that is also focusing on reutilizing brewer spent grain in different food categories, and also trying to study how fermentation can improve the quality.
Okay, thank you. Anyone has a question? I myself was in Germany some 1.5 months ago, and I tasted from one brewery's bread. The bread actually, it was directly made from the BHG, so it was not fermented, and it was a little bit fragile, so it's it was not really the consistency itself was not good, but the taste was very good.
I think this is also our experience, and the reason why we wanted to focus on simple, feasible technologies on how to improve the quality of the spent grain, because it is, after all, most of it lignin. So it needs a little bit of processing to improve its functionality in bread or in other food product. But I agree with you that the taste can be actually good, and again, it blends well. Cereal in cereal, so it belongs there in a way, in our experience.
Yeah, and I do agree that actually we have to use it in food, because I think we are having highest quality grains we are using for the beer, and then we are throwing it away. We are giving it to animals, but I think animals can be fed with a lower quality product. And here we have also extracted already all the sugars away. We have more concentrated proteins in it and hemicelluloses. So I think we have higher quality product already as it from the very beginning. So yeah, but thank you.
Thank you.
It was very good presentation. So I think now we jump to the third one. Discuss where it can be used in cosmetic products. So Heli Pirinen from Idea Natura now is your floors, your screen, your floors. We don't have floor here anymore.
Okay. Hello to everyone. I'm Heli Pirinen and coming from Idea Nature company. I'm the CEO and head of product development, and we do product development from to foods and animal welfare, animal feeds, and also cosmetics. And cosmetics, it's now the issue I'm talking about. Of course, we do also training and mentoring, not only the product development, but main customers we do like business to business. So we'll go on. We have now made some literature review and also product development with the side streams from spent grain, and there has been the pure spent grain and also these proteins which have been extracted, and there has been protein hydrolysates which have been extracted by enzymes, and there has been alkylase enzyme which is used, and also there is some also these other things which have been done. So there are different kind of side streams from these spent grains. There could be also, there is coming hemicellulose, there is coming this lignin, and there is also coming this starch. But now on, we have only concentrated to those proteins, and they are very interesting. We have done some recipes to cosmetics from these spent grains as in different quality, and also this extracted protein, and then this enzymide protein hydrolysates. And you see the photos here. They are different looking, because the spent grains only has it's kind of a rough material to use. And then this extracted protein is like a brown, not very good going water. But these enzymized protein hydrolysates are very interesting because they are going to liquid very easily and can be used very easily in cosmetic products which have the water inside the product. Possibilities in cosmetic products for these protein extractions are there are very large area, and there in commercially there are used very much the same kind of products, but not from the barley. Barley is quite new coming component in cosmetics. But of course there are skin creams, there are hair shampoos, there are hair conditioners, shower gels, then different kind of peeling products. And I was thinking that this enzyme hydrolysed protein is very good for makeups and also for hair coloring because of the brown color. And then there are some anti-odor products like deodorants and antiperspirants, which can be also done from these products or raw materials. And how the role of protein in cosmetics, they have different functions. They are moisturizing agents, they can increase elasticity, they can improve skin tightness, and also stimulate cell growth. They are emollients, like they are softening and smoothening the skin. And also they have anti-irritating effect. So you can use those products also in cosmetic creams, like making them anti-irritating. Of course, there is also technical function. They have different kind of buffering properties and also this viscosity control. Concentrations in recipe are very low. They can be 0.1 to 2%, or as you will see future, there is bigger concentrations, which I tried in one formulation. Well, then the basics, the spent grains coming directly, and of course they are also dried, which we used is like in coating, which is the chemical ingredient profile, and there are lots of cosmetic ingredients. Says that there is Hordeum vulgare extract, and it is an extract of cereal grass of paleo, Hordeum vulgare, which can be used. There are few more also these Hordeum vulgare products which can be used in cosmetics, but very few. And we tried these spent grains directly, like different particle sizes. In the exfoliation products, we wanted to have this mechanical exfoliation response. So these particles were peeling dead skin cells away, and that freshes the skin and makes it more available to other cosmetic products like creams and also these humectants. Of course, there is also because it's quite big, the protein content, it's also acting as a humectant as itself. And this humectant is like hygroscopic material. It takes moisture from the environment and put it to the skin. So the water is very important fact in our cosmetic products, and how it affects to your better looking. And then there is this texture of the product protein structure, which also involves how it works in the skin products. Then we had the sodium hydroxide extracted protein. So there is very much this antimicrobial effects. Also, this antioxidant effect is very important in cosmetic products, as it was in food. And this humectant also affected is very, very important. So these are the main things we want to put to cosmetic products. So if we have a crazy skin, we want there this antimicrobial effect. And of course, this antioxidant effect is for looking young, and also the cells are not going so fast older. And this humectant effect gives us a good look, because the water is important in these cosmetic products. There is one example of the product we made. This is a face mask. It's like a gel, and there is this barley bran protein, and we put there some xanthan, but you can also use gelatin or agar-agar there. And then there is sorbitol or erythritol we can use, and then liquid. And of course, there is also other active ingredients. You can put there keratolytic ingredients like allantoin, and also some preservative you must have in this kind of product, because there is water so much. This is like a gel you put to your face, and then you get this antioxidant and humectant effect in face mask. Very interesting is this enzymide protein hydrolysates, and this enzyme alkalase also. We are trying also to look if this alkalase is still in this protein fraction. So it could also be like a keratinolyte, like the better one maybe than this papain, which is used very much in cosmetic products. So I'm very interested on that, and I have now discussed also in Oulu University, they have equipment to check is there this enzyme activity that's alkali still in there. So this could be like a product, very interesting product because of this enzyme, but also because of this protein effect in cosmetics. This exfoliating effects it's very important. And of course, this when this protein is hydrolyzed, it changes the molecular weight changes, the charge of the protein changes, and the most important, it's more solubility to water. Its viscosity changes. There is sensory properties, and also it gets some emulsifying and foaming behavior, which gives us more products where we can use for shampoos or soaps or so far for emulsions. So we don't have yet emulsifiers which could be done in Finland. So we are now all ordering somewhere else. We have no this emulsifier production in homeland. So it's interesting to find out how much this enzymized protein hydrolysate can be emulsifying a product. Can we do only by that like an emulsion? Of course, this is very interesting in food sector also, but now I'm talking about the cosmetics. There is one face serum product we were trying, and there is this enzymized protein hydrolysate in it. And as you see, there is a water base, and then there is oil base, and this is like an emulsion. And there is plant extract also involved. We want some active ingredients also from other plants in there. And then there is that allantoin, which was keratinolytic. And then there is this hydrolysated protein. And of course, there is xanthan. And in the oil base, we have glycerol stearat SE and jojoba oil, and also squalane, which makes this more more better feeling in skin. And then this preservative also. Possibilities in cosmetics could be also this Hordeum vulgarisera, which is also found from the causing list. And it is a wax of spent grain of the barley. And I would like to try also that and take out and how much comes from the this spent grain out of this wax, because waxes are also raw materials which we don't have yet in our own. We don't have companies our own who product these wax products. Only pea wax is coming from Finland, but we need also waxes from plant bases. So this vegan cosmetic sector is growing, and of course then we cannot use any animal-based products or raw materials in those products in cosmetics. Then there is this probiotic cosmetics, which is quite new also in Finland, and of course probiotic and prebiotic cosmetics. But it would be interesting to look about the carbohydrates. Could it be a base for this probiotic microbe growing? And then these other also these components like this hemicellulose, lignin, and starch. We used starch as like I showed you the recipe of the cosmetic product. There was this xanthan here, but we could also use starch here to make the firm to the cosmetic product. Okay, my session was here, and we are continuing our work. Thank you. You can contact me also by email. There is my email address. If you want to ask more, of course, you can ask now questions also.
Thank you, very inspiring. So where I can get those mixes, I can try on my face.
I can send.
Okay. Are there any questions? Yes. Rossana?
Yes, hi, thank you for your presentation. It was very, very interesting. I wanted to know if you know what stages the protein needs to have to be functional. Does it have to be intact, or can it be also partly hydrolyzed, or amino acids, or?
The component of amino acids are very important. And of course, this keratolytic, this enzyme used also affects what kind of protein comes out. So here was alkalas because it was in Centria. They did the sample for me. But of course, we could try also other enzymes and try and find out if there is different kind of things it makes to protein.
Okay, thank you.
Some other questions? Okay, very interesting. My question would be, can it be combined that, for example, you make only one fraction, one type of protein, and then part of it goes to food industry, another part you can use also for cosmetics, so that with the same process, actually with the same product, you can go into different applications. I don't know, maybe Rossana could also help here, or how you see this, because I think you both could collaborate on that.
Yes, I think it's possible, and of course we must look. It's the same. The same safety must be in cosmetics and food, I think. So there is different laws behind these products. So in cosmetics there is I think there is more raw materials we can use than in food, because there is quite strict law in Finland in food sector. But what about, can you, Rossana, also give your opinion?
Can you please repeat the question, Egidija, so I'm sure what you meant?
No, I was just meaning that can in principle be done the same type of protein, and then it would have different applications. One application would be in the food industry, and another one would be the cosmetics, so that you don't need to run two different processes to produce different raw material for the application.
I have to say I'm not. I haven't had this experience before, but I imagine that if the process is done food grade, it would fit the cosmetic sector as well, I guess, because food grade is the highest. At least I think. Of course, there is also pharmaceutical grade, but probably this is something that goes into regulation that honestly I'm not aware of. But I would say that perhaps food grade should satisfy. I would like also to comment on the functionality of the different compounds, and I think Brewer's grade might be great also to grow probiotic, because it's full of probiotic fibers that might just need perhaps to be prepared for the growth of probiotics. So good luck with that application. It would be great to have on the market.
Thank you. Any other questions? We have one question in chat. Has this been tried out in fish to strengthen the skin and avoid wounding? I think it was meant about some extracts from fish. I don't know, oil or protein, or what would be the product from the fish used in cosmetics?
I was actually referring to the product that was discussed now, the skin products that were discussed, if it has been tested out in fish feed to strengthen the skin of the fish, because I mean wounds in fish for fish farms is a huge problem. So I was wondering whether these products has been tested out for fish farms.
Well, not in our project at least, so that I know, and I'm not fish specialist, so can't say, but I think we have online, don't see, we have somebody from Nibia in Norway. Maybe they know.
Well, I'm from Nibia myself, so.
Are you from the, okay, so I don't know.
But yeah.
Here, so somebody else, if you know the answer.
I was saying I know for Ireland, I don't think so, but I could try and find out.
Good. Yeah, well, I was just curious because we have a project where we're looking into plant extracts, and that one of the aspects is testing on fish skin to see if they are worth getting scars and wounds, or we can kind of increase the skin strength. So I was just curious.
Very interesting approach. So you feed fish with some protein and then you expect that fish skin is improving.
No, this is herbal extracts. So this is bioactive compounds from the herbs. But it's just that in the presentation now it was mentioned this about the antimicrobial effect and increasing the humidity of the skin and the elasticity and what have you. So I was therefore wondering whether it also could have an effect on fish skin.
Okay. Okay, some other comments of the day, or does some brewery want to say own opinion where breweries are going now, and do you see the market for your side stream products, or do you see the market in general for the new products from brewery? It seems to be quiet. I think it was a long day. It's also extended a little bit than it was planned, but I think the conversations and the stories we have to share are important, and time is always important, but sometimes we can spend more time on meeting people and discussing and getting new inspiration. So I would say that thank you very much for everyone participating today and everyone who has participated also in the 2 other days. Take contact to us with any ideas you have, any questions you have, and we try to answer. If we don't know the answer ourselves, we try to find out who knows the answer. So that's what we are for, as we are claiming we are matchmakers. So we know a lot of different research institutions, a lot of different companies, and we participate in a lot of different events, so maybe eventually we know answer to your question, or maybe we know who knows that. So just take contact, and let's hope that in the future we have some new products coming out also from the breweries. So bye from my side. Thank you also all the presenters, especially thanks.
Yeah, thank you very much. It was very interesting.
Okay. So goodbye, everyone, and here to next time, check our technology innovation platform, what we have in next half year coming up in there. Okay, goodbye, everyone.